everyone. Everybody here? Yes, okay. Welcome to the 7th Open Science Training Series of the Douglas. Today we're featuring Alisa Rod, presenting on the balancing openness and privacy considerations for managing and sharing sensitive research data. Alisa Rod is the Research Data Management Specialist at McGill University Libraries, where she provides individual consulting to campus researchers and research groups on fundamentals of research data management issues, including data management planning, funding agency requirements, data citation practices, open data, and research data lifecycle management. Alisa also helps researchers publish data with McGill's Institutional Research Data Repository. She has a master's in information studies from McGill and an MA and PhD in political science from the University of California at Santa Barbara. Welcome, Alisa.
Thank you. Thanks for having me. Oh, clapping already. Yes, after every slide. Let's do it. All right, so I'm going to talk a little bit about what is research data management in general, so try to frame the context of what we're talking about when we're thinking about managing and sharing data. What does that mean? When does it happen? What is the regulatory context we're working in with sensitive data at a high level? Like what are the new issues, new challenges with that, especially if we're working with data in Quebec? What are some ways that we can manage sensitive research data in terms of what are some best practices or current practices around that? I'm going to talk a bit about open data sharing. I know there was another talk exclusively about that. I'm going to talk about it in the context of like, how do we do that? How can we openly share our data when they're sensitive? Those things are mutually exclusive, actually, right? If something is open, it shouldn't be sensitive. If you want to share your sensitive data, you shouldn't share it openly. What are some of the workarounds? What are some ways to do that while safeguarding the data and or, aligning with open science principles on the other side? So what are some ways we can do that? I'm going to talk about the FAIR principles, just in terms of the context of using that as a framework to think about how to do open science with data that cannot be made like not sensitive. So that's sort of thinking about different ways of interpreting open science in the context of a data set where you can't remove all the sensitivities involved with that. Then I'd be happy to have a discussion if anyone has any questions or is interested in chatting more about any of these topics. So in terms of what's research data management, what are we talking about? What are we thinking about? So whether we're working with sensitive data or any other kind of data, it's usually in the context of thinking through a life cycle for that data. So you're collecting it, you're creating it, but then you're also sort of thinking about how I'm going to analyze it. Who am I sharing the data with? Where is it going to live when I'm working on my project? Where is it going to live when I have different phases of my project? What am I going to do with it when I'm finished with my project? These are all things we're trying to get people to think about in advance. And so there are some mechanisms that are that sort of force people to do this in terms of like, if you need to apply for an ethics application, then you will have to have planned a lot of this in advance. But not necessarily that piece at the end of what precisely am I doing with the data? Where exactly am I putting it? What's going to happen to it in 10 years, 20 years? How can I prepare it so that it can be reused to the full extent of its value for the long term? So it's not as simple as just putting something, making it openly available or making it available in some kind of way. There are a lot of things that we have to think about in this process to make sure that it can be as open as it possibly can and have value for long term. So what are we talking about when we mean sensitive research data? And I'm shamelessly using a definition that I came up with in a chapter I wrote about sensitive data for a open educational resource, which is an open textbook on RDM in the Canadian context. So I have a citation. I will share the slides, so you'll have that link. So my co-author and I of that chapter came up with this definition because we found that a lot of the ones that were out there kind of define sensitive data as data that are sensitive, defining it by its own term. So we distilled that down to it's data that can't be shared, external to whoever's collecting it or working on it or who has the right to access those data, without violating the trust or risking harm to an individual entity or community, right? So the piece there that's important is the risk of harm, right? So if it's sensitive, it means you're risking harming someone by releasing it. So if something is open, it shouldn't be sensitive, right? If it's fully open access. So what are some ways we can balance those things? I want to switch to the browser, but I'm worried. Let's see. Let's see how it goes. Okay, so I just wanted to point out that we've come up with at McGill a sensitive research data classification tool. This is from an institutional perspective, like a way to categorize sensitive data according to how sensitive it is. Yeah. Oh, shoot. Yes. I'm going to share the entire screen here. That makes sense. Screen. There we go. So this is the website of the Digital Research Services Hub, which is a collaboration between libraries, VPRI, so that's research admin at McGill Central, and IT at McGill Central. So we've come up with this tool with a lot of consultation with different units that might be involved in having a stake in understanding or managing sensitive data. So there's, of course, this classification very high. We've tried to come up with some research examples, things like something causing severe harm. There's the classic personal health information is considered very high sensitivity, financial records, things like of that nature. And then we have a list of like the potential negative impacts of a breach of those data. So what are the examples and what is the potential for harm? And even down to low. So you can see there's nothing on that scale that says that there's some no sensitivity level. Basically, when you're working with research data, there's always going to be something to consider, whether it's licenses, copyright, intellectual property, ownership of the data, all these things that even if you're want to make something perfectly open, there's a lot of implications or consequences of that, of who's using it and secondary reuse. Are they doing something malicious? So things to think through. Even data that are public could have some sensitivity to it. So this is just meant as like guidance. And if you're requesting software through Central McGill, they might ask you to say how sensitive your data is going to be or that you anticipate it will be according to this scale, so that they have some sense of what might be the cybersecurity risks or the risks in terms of like the actual management or movement of that data. So it's meant sort of like as a way to gauge what's appropriate in terms of the way you're managing it. So this is from the Central McGill. I'm going to pull up the PowerPoint again. All right, so that's a handy tool. And then I wanted to talk a little bit about the regulatory and policy context that we're working in now when we work with sensitive data, especially human data. So for the most part, when we talk about sensitive data, 90% of that is going to be human-derived data. So some kind of information that comes from humans in some way. And that's going to be governed by like TCPS2 laws, all those kinds of things. And I just want to make a note as well that your data can change its level of sensitivity over the course of a project. So that's also something to consider, is when will it be at its highest sensitivity? Are you collecting consent forms with people's names on them? Are they attached to data? Do you have data with names and things that can really identify people? Is it really sensitive information about something that's considered like a social taboo? Is it a sensitive population like children? So some of these considerations, like at what point in time is it the most sensitive and how are you managing at that point in time? Over time, over the life cycle of your project, it may become low sensitive because you might remove some of that information, right? Or you might change it so that you can't associate it with a person specifically. Then it's not as sensitive anymore. So it's not just a straightforward, it's high or low. It's what is it at what point during my project? Okay, so I want to talk a little bit about the regulatory and policy context, but I'm going to say clearly that I am not a lawyer. I'm not giving legal advice. I am telling you my perspective of like what this means in a high level way. Okay, so just take it as you want. Always go ask the organization or unit that's responsible for like making actual decisions about how to interpret these things. I just wanted to point out that it is very complicated, right? So we have institutional policies and directives, things like the cloud directive at McGill. We have the governance of personal information policy. We have the regulation on the conduct of research. We have the ethical conduct of research involving human participants policy. That's at the institutional level. Then you have funder policies and directives. So the tri-agencies came out with a research data management policy a couple years ago. They have some expectations. They are going to start rolling out a data deposit requirement. They said next year for grants that are awarded starting next year. They also said they could change that, so they could push it back. But that's what they're anticipating and they did a lot of public consultations. So there were people who asked, what about when you're collecting sensitive data where it like really can't be made public? and it can't be sort of stripped of that sensitivity. And their response was sort of like, we're not worried about that. We feel like there's always some kind of way to do something that aligns with at least the FAIR principles in that context. So I'll talk a little bit more about how that could be accurate, but that seems to be their perspective on it. And then we have legislation that we might be that we might be accountable to. So in Quebec, we have the new version of the Access Act. I know there's a medical one, but I'm going to talk about just the Loi 25 because the medical one, I think, only applies to the clinical side, and the Loi 25 would apply to the research side of the data. So there's some distinctions there that have to be hashed out. Again, that is like, take with a grain of salt, please. There's also, if you're working with someone in the European Union, you might have to comply with GDPR regulations, so their privacy regulations, things like that. So just in terms of like, how is Loi 25 changing the context here? So it set out responsibilities for organizations in Quebec, which includes universities, so public organizations, that includes universities, about definitions related to securely managing and working with personal information. So it's about information that you collect where it will have some personal information, whether or not later it won't have that attached to it, right? And it's sort of fully phased out, although they do keep passing sort of like regulations to amend this to like clarify things. So every year in May, we're like, oh no, what's coming? But so far there's been a few. So there's one where they talk about what do they mean by personal information? So something critical here is that it talks about information that directly or indirectly identifies someone. So they're including indirect identifiers, which I'll talk a little bit more about. Then they also have a second category called sensitive personal information that's presumably even more sensitive than regular personal information. And that's just that you would have an expectation of privacy around that information, things like medical data, biometric data, et cetera. They also have a regulation that came out last year specifically about anonymizing personal information. So they make a distinction between de-identified personal information and anonymized. In this case, they've noted that de-identified personal information is still personal information, which is kind of a departure from the way that researchers have thought about this in the past. So they're sort of saying if it's de-identified, it doesn't mean that you can't re-identify someone. It means you can't easily re-identify them, but there's still some risk. And you must still take measures to like limit that risk, but it's still considered personal information, which is still then under this act, right? Anonymized information is no longer considered personal information, but it must be irreversibly stripped of direct and indirect identifiers. And they specifically mention that that means you cannot keep a key that allows you to relink that data to like their identifiable information. That can't, even if it's kept separately, as long as that key exists, it is still considered not anonymized information, if that makes sense. And then there's also, of course, TCPS2. So that's our ethical framework in Canada that we have to follow. So that was updated a few years ago in 2022. And one major difference between the previous version and the new version is that they've said there is no more blanket consent, or they've explicitly said you can't blanket consent participants to future research. They are allowing broad consent, which means that you can ask your participants, do you consent to having your data deposited somewhere for some future unspecified research purpose, right? That's fine. So that means people could reuse it for many other studies. The problem is that there does have to be a restriction. It can't be fully unrestricted according to this concept. So that means you have to say for research or for research in this discipline or for similar research. So it can't just be for any purpose as far as we've heard the interpretation is. And this is something we're grappling with now in terms of how to align that with fully open access data. Are those two things incompatible? And this is a big debate that's happening right now. Again, your local institution at REB will interpret this. So you might have very different interpretations of this depending on what institution you're at. A lot of that is because the language around this, and they have a whole guidance document about interpreting some of this text, can be a bit vague and can be a bit open, but it is up to the local board to decide how to interpret that. Okay, so then what are some ways we can manage sensitive data while we're actually working on it with an aim that we want to make it available or do open science, right? We want to do open science. how can we do some work on our data to, given all this context in terms of like policies and regulations and privacy. Okay, so I have some resources that I'm just going to highlight because there's a lot out there that can help with guidance. The Digital Research Alliance of Canada has a sensitive data toolkit for researchers. So there's 3 parts. One of them is sort of like a glossary of terms. So like what's the difference between anonymous, anonymized, that kind of thing. One has boilerplate template language for consent forms. So if you want to consent participants to later have their data be in a repository, it has some like language that you could adapt for your context, for example. I will point out that I'm in a community of practice that is revising these right now. So there will be a new version of these probably this year. These were published in 2020, I believe. So they're out of date. It's been 5 years, but they're like almost out of date at this point. But a new version is coming. There's some other resources here as well. Like there's a network in the US that has released guidance on how you prepare data that's going to be published if it had some human participant information involved with that. And then there's just thinking about personal information in general and how we deal with it. So I'm sure people are familiar with this concept of direct versus indirect. I'm just going to go through it so we can do a couple exercises. But essentially, there's that 2 pieces of kinds of information. There's directly identifying, so some piece of information that is unique to an individual, and indirect identifiers, which means when you combine multiple indirect identifiers, you could then maybe identify a unique individual. So let's consider this comma delimited data set here. You have first name, postal code, age, gender, and email address. Any of these direct identifiers? Email, yes, absolutely. Any others? Fun fact, exact age can be a direct identifier if you're very old. So if you're like above 100 or something to that effect, and it depends on where you are and what context. So again, if it's a debate about whether it is or isn't, but just something to be aware of. I like to cite this study by Latanya Sweeney, which was done a long time ago, like about 25 years ago. But they took US Census data, aggregate US Census data, and other administrative data, and they were able to re-identify people based on just their zip code, gender, and date of birth from the 1990 census, something like almost 90%. They redid this many times with other kinds of data and were able to statistically re-identify, like use statistical methods to do that. So that's just to say that even some of these indirect identifiers at this point in time, so if you Googled someone's first name with their postal code, you'd probably find them if they have a name like Nuri, for example, and they're in Montreal. Maybe not Sandy, but it depends. So it also depends on the personal characteristics of the individual as well a bit. And if your name is like John Smith, is that actually a direct identifier? If you're the only John Smith in a data set, fine, or in Montreal. But if there's 200 of you, then I don't know. So there's a bit of flexibility there, open to interpretation. We always have to take a critical eye to this to think about what are the risks for these actual people that were in this study, right? So just in general, when we think about direct identifiers, we're talking about things like name, normally address. That can be like a static IP address as well. So there's some software tools that like collect that as part of the metadata of the tool. For a long time, Qualtrics would stamp the IP address of the respondent to their response. And you'd have to manually override that because it was a default. So you would export this data and you would have their IP address in the data set. So if you had guaranteed that it was anonymous, that right there would have violated that consent. Things like unique IDs, so student ID, driver's license, etc. And then there's fun indirect identifiers where we sit down and we think about what could possibly be used to like re-identify people, like what combination of these things. So age, again, HIPAA in the US says if you're over 89, it can be considered a direct identifier. I feel like that's debatable and it's a US thing, but still something to consider. Geographic location, the smaller the location, the more identifiable a person is, right? In New York City, so you have a super dense population, some zip codes are one building in New York City. So you would know that someone lives at that apartment building if you had their zip code. Things like your place of employment. If you have a rare disease, you're always considered to be like an identifier. Things if you have like rare demographics, like someone has 20 kids, they probably have a reality show about them. So you could probably just Google guy with 20 kids Montreal, you'd find his reality show or whatever, and you'd be like, it's that person. So in terms of ways to think about protecting participant privacy, what levels of activities do we have to do when we're managing these data? We collect some data that has sensitivity. It has indirect identifiers. It has direct identifiers. We analyze it. We want to share it at some point. What do we have to do through that pipeline to get to the point where we could comfortably share it, either with people not in our own research team or broadly, right? So what are some things we have to consider? First is like how easy would it be to identify people who were in your study? If it was fully anonymous, meaning that it was never collected with any direct identifiers, it would be very difficult, right? So you could feel that that's safer. If it's anonymized, you must ensure that it's irreversible. You can't keep a code that connects an ID on the data set to someone's actual personal information. That has to be destroyed for it to be considered anonymized. And then there's de-identified, which is this kind of gray area of I'm still keeping this code because I may have to contact people if they want to withdraw, if I have to inform them about something, or if I'm doing a longitudinal study, for example, and I do need to connect them. But if I de-identify it to a certain extent, can it be shared openly to a certain extent, right? Maybe not fully openly, but to some extent. So how do we deal with indirect identifiers? I've included a link to the Finnish Social Science Data Archives anonymization guide, which is quite good, quite random, but for some reason they have a very, very fabulous anonymization guide. But basically there's a few things that people do. So there's recoding values. Like let's say you collected people's exact age. So you have someone's 67, someone's 25. Maybe you recode it as like a range, 20 to 30, 31 to 40, right? So that you don't have a precise age for the person. Stuff like that, where it's possible, where it doesn't affect the analysis, right? So if you do need that to be numeric and not categorical, then that can be a challenge, but you have to balance that with how easy it is to then identify the people in your study, right? In the past, people would just remove observations or full variables from either their data set that they're working on and then release, or some version of the data set that they then release. That can create problems with transparency. So that is maybe competing with open science principles, right? So if you remove something that you initially that you initially included, why did you ask it? Why did you collect it? Are you reporting on those values? Then there is a sort of tension with that transparency element. If you have qualitative information like interview transcripts, or if you ask to have a questionnaire that you collected some information and you have some open-ended text, you could redact anything that people say that kind of identifies them. So that's a very common thing to do. With images or video or audio, it can be distorted. So images can be blurred. That's considered like a safe technique. I'm going to talk a little bit about the statistical methods, and not to demonstrate it, but just to explain what are they? They're still the ones that are being talked about and used. And what are some of the considerations you have to think about when you're working with those kinds of ways of anonymizing data? Then there's like fancier statistical techniques like differential privacy, where you add noise to your data set. So you add fake observations that don't change the overall aggregate statistics, or you slightly modify some variables for some observations where it doesn't really change the measure itself, but does maintain that overall statistic. But then you can't know what the real value was of some of those observations. And then for qualitative data, of course, it's aggregating proper nouns, things like saying village instead of the specific town where someone is from, for example. But the goal in both cases is that you can't identify people in the data set itself, nor by combining it with any other data. And that's really tough to determine. You can do some due diligence, look around what other kind of data sets are out there that might have the same variables for the same people with identifiers, and try to figure out if that exists. As long as you do due diligence, that's usually fine. But now in this era of like, I know I'm going to sound like a grandma. But like in this era of AI, who knows, like what's out there and what can be connected and things like that. So it's becoming a bit more complex and challenging to think through the consequences of this. So I'm going to talk just a bit about statistical disclosure risk assessment. So these are things like K-anonymity and L-diversity, different techniques that you might use to statistically transform data or assess the data in terms of the risk that someone could be identified. In the Quebec's new, it's fine. In Quebec's new regulation that was published last year on anonymization guidance for the Access Act, they specifically say that you have to use best practice statistical methods to anonymize your data set by an expert in those methods. It's like very specific, very intense. And what does that mean? Again, open to interpretation, I suppose, but this is normally what we think of when someone would say that. We would think these specific types of risk assessment measures that are statistical. So I'm just going to walk through what it means. Let's say we have this de-identified data set on media habits. We don't have the person's name. We don't have the specific ID for them. We collected their specific age, their gender, their postal code for some reason, and how many hours a week they watch Netflix. So you can see there's an embarrassing category of more than 60 hours a week. Or like, awesome. I don't know, whatever depending on your perspective of how much you love Netflix and how much you love TV. Let's say there's a volunteer public directory that has this person's name, Stephanie Gingras, her address, her gender, and her year of birth for some reason in this public directory. So you can see that you could match these two data sets on these three items and figure out, hey, Stephanie watches more than 60 hours of Netflix a week. That's probably her. Because there's only one person in this whole data set with those three characteristics, who's 77, female, and lives in that postal code. Therefore, it is almost certain that it's this person. So K-anonymity is a sort of way of assessing your data set to see how many sample uniques you have. How many people in your data set have unique combination of demographic characteristics such that it's likely that there's a higher risk of identifying them with other data sets. So if you have a K equals 1, that means they're the only one in your data set with those three things. So that's a high risk. It's a bit arbitrary. Normally people set it at 5, so K of 5. So like there you have to have 4 twins or quadruplets or centuplets in your data set. 5 people have to have those same 3 characteristics in order for you to say you would not know which one is Stephanie, like in this data set. So it depends on how many people you have in your sample. If your sample is the whole population, the risk is higher, right? If it's a small portion of the population, the risk is lower. But if you have postal code, the full postal code or a small geographic area, it's easier to re-identify people. So these are things that have to be considered. So the statistical assessment you can plug this into a lot of different programs or tools where you can run the K-anonymity, whatever package it is in your program, and it will tell you like these observations are unique, or this is your threshold. You have this many at K of 4, many at K of 5, this at K of 3, you have a few of K at 1. Then you have to think about, am I adding fake observations that mirror those? Am I taking out postal code? Like, what am I going to do to ensure that there's not a unique person with indirect identifiers? The other issue is that, okay, so let's say you're like, oh, phew, I have 3 people in Montreal. I've decided I'm going to aggregate the age. So I'm going to just say that there's a range of like 90 to 100. So I'm not going to have their precise age. I'm not going to have their postal code. I'm just going to put the city they live in, Montreal. And, I have a K of 3 of this person, like people who identify themselves as being female, which should be gender, but an age range in that range, they're from Montreal. I have 3 people with those characteristics. I'm fine. Problem is that they all have the same outcome. So they all watch more than 60 hours of Netflix a week. So if you meet someone who's like 99 years old from Montreal and who's female, you'll be like, she watches a ton of Netflix because I don't even need to know which one this is. So that's the L diversity aspect of it, of like, not only do you need many twins, but they need to have diverse outcomes on the outcome side in order to say that you can't identify some information about that person. Once you start doing this and really transforming the data or moving things around, this will degrade the data, right? This will degrade your ability to maybe do as much with the data. It won't be as similar to the raw version that you collected. It'll have some manipulation. So these are trade-offs, right? I want to release my data set. These variables aren't important enough to have very precise information about, or I don't need one or more of these for my hypothesis, so I can remove it on my side. So these are things that have to be sort of considered. There is no like perfect solution for this. So I'm also going to talk a tiny bit about aggregate statistics and privacy. So a lot of the times we'll see people say in their consent forms, I'm going to only release aggregate statistics. Therefore, there's no risk to my participants. The way I said it in a kind of sarcastic tone means there probably is, so I've kind of like already told you. But here's an example. A class has 5 students. The teacher writes the average exam score on the board, 85%. 5 students, average exam score, 85%. One student moves to another town and drops the class. The teacher says, okay, the new average for that test is 84% for the 4 students that are left. Has the student's privacy been violated, the one who moved? Do we know what their score is? Yes. What is it? I'll show you. We're going to do some very simple algebra here. I'm not sure it meets the threshold of algebra, but I'm reaching back to like whatever, 7th grade. I'm like, is it algebra or is it just simple math? So we have 5 people plus our moving student divided by 5, 85. That's how you calculate an average. Then those same 4 students divided by 4, 84. If we do 85 times 5 versus 85 times 4, subtract the difference is 89. So yes, we could precisely know what that person's score was based just on doing some very simple math. This is a very, very like basic example of this concept, but there are so many sophisticated tools out there and people with very, very, very high levels of sophisticated statistical knowledge this is how they were able to do this with this US Census data. They were able to take aggregate data and identify individuals with other data sets using these kinds of methods, right? So using just this kind of logic of like, if you remove people here and there, what do you have left? Okay, we know who that person is. Yes, they did. Their students' privacy has been violated. The teacher disclosed that student's exam score to the entire class, if the class was clever, which we don't know. But basically, the point is releasing statistics can tell us information about individuals. So it's another layer of consideration that we have to think about. And this is what has led to a technique called differential privacy becoming very popular. Because what it does is it's a statistical method where you add noise to your data set. Therefore, if you remove one person or you change a few things, you can't actually reverse engineer the person who left or whatever because you have fake data in there as well, right? And that's not going to change. It's not going to change the overall statistics necessarily, but it's going to change the individual level observations. But it's very difficult. And it has a lot of consequences as well. So I'll talk a little bit about that. So just in general, important considerations to think about of trying to like make your data set anonymized so that it can be openly available or published in some kind of way. There's a lot of work that goes into it. It's not impossible, but there's a lot of work. And the more regulations and more policies we have on top of that, the more there are very advanced tools that can be used to connect different data sets around different domains, the harder it's going to become. And so it's just something that we have to keep in mind and be mindful of and have some expertise in as well. So how do we balance? We always have to consider, how do we balance the privacy of these participants in our study and the usefulness of the data? So the more of these statistical things you do to like ring your data set so that it's anonymous, the less useful it might be because you're sort of, aggregating a lot of things that maybe you actually needed precise information about. And you have to think about what is the impact. So a lot of people will just take their data set and say, I'm running this, I'm going to identify the K and I'm going to try to like mitigate that. But you should check before and after the descriptive stats for like important variables. So if it's changing the mean of a variable that you care about, if it's changing the distribution of a variable you care about, then maybe you would have to do something in a different way when you're adding noise or doing some of these techniques. Another thing to consider is not just does it change the distribution of that single variable or the way that it looks and the sort of statistics around that, does it change the relationship between different variables that you're interested in? And that cannot, sometimes you can do one and not the other. And so there's a point in time when you might say, I can't anonymize this effectively. And so now what do I do, right? Or I've done it, but here are all these things I'm going to have to disclose about like the difference between the raw data and then the final version of this data set that I'm calling anonymized, right? That people have to be aware of in terms of like the differences in what you're going to get when you run certain types of analyses. Also, anonymization is an ongoing process. As new tools, as new technology becomes available, as new data gets published, these risks can increase and they can change for the data set. If you publish something 20 years ago, you might have to reevaluate how anonymous it is in today's context, right? So you might have to do that on an ongoing basis. Usually people combine multiple approaches. So usually you don't just take one side, one method or another, you combine a few things to try to increase the usefulness of the data and also decrease the risk of the breach of that to your participants. This is why it's good to do data management planning from the beginning of a project, because then you think through these things in advance, think through the consequences of collecting certain kinds of information. Oh, it's fun to collect age and date of birth and whatever, tons of stuff about people. But then how am I going to deal with that at the end, right? What is my hypothesis I'm trying to test? Does this help me? Is this going to make it harder to do something with this data in the future? Those kinds of things. And that there is no method that can eliminate all risks. So what we're trying to do is just get it to the lowest level we think is reasonable for the people who participated and what we promised them when they consented to our study. A few notes about other sort of practical things. So a lot of this also involves thinking about where are you putting the data? How are you preserving it? How are you backing it up? What's the security around that information? Are you encrypting devices? Do you have an encrypted device already? Are you accessing things via VPN when you're off-site? Do you password protect your backups? All those kinds of activities. For storage and sharing, when you use your institution's provided cloud-based storage or local storage, that's always going to be more secure than using something personal, of course. And just to flag that there are new things developing all the time. There's this huge project with Calcul, Quebec called Secure Data for Health. So they're going to spin up a secure health cloud over there and allow people to work with health data on the high performance computing nodes, which is new. So that's cool because in the past and currently you're not supposed to put sensitive data over there. So this is going to allow for more activities for people who collect sensitive data who want to store, analyze, and share it in a sensitive format. So there's going to be new things developing like that. And just to note that if you're on the McGill side and you want to use a specific software for research that's not approved, you would have to go through a process with IT to sort of request that they vet it for you and give you a sort of profile of how secure it is. And then you take that to the REB and you say, based on this and considering, the sensitivity of my data, I think it's fine. And there's a whole process for that. So just something to be aware of. Okay, so that was like the bummer side of things, like, oh, sensitive data, what can I do with it? Can I ever share it? Can it ever be anonymous? And then I'm going to shift to what are some ways we can share sensitive data? What are some ways we can do open science even with sensitive data? So I started with open data sharing, which is a bad transition because we can't share openly sensitive data. If it's sensitive, it can't be open, right? If it's open, it should not be sensitive because sensitive means risk of harm. So we don't want to be doing that. But I just wanted to put into context, what is one side of the spectrum versus others in terms of doing open science and what are some things we can do? So open access data, this is critical because it's data that can be freely accessed, reused, remixed with no restrictions at all, right? And that will usually conflict with this concept of you have some data from humans, you have to make a restricted promise to them about how the data will be reused. Even if you say it'll be reused for unspecified research, you're still saying research. You're not saying an AI like company can take the data and train its model with your data, right? So that's what an open access data license allows, or an open access data. It's anything. It's not just research. But the benefits of making data open access or open, of course, this facilitates open science. It's a piece of open science. It's not, the cornerstone, but it's a big part of it. It increases the visibility and usage and impact of research. Critically, and this also ties in with open science, it increases confidence and trust, right? So if people can verify your findings, can see what you've done, they will have more trust in what you're saying when you're reporting the findings of your study. And some funders and journals are starting to mandate this, although there will be caveats and considerations for sensitive data that will still fall under these mandates. So what I'm trying to say is that you can do open science by making your data fair, fits a lot of these criteria, but it is not making your data open access if it's sensitive, right? So just because you can't make it fully open access, if it has human participants with some kind of risk of re-identification, it doesn't mean you can't do open science, because open science is about transparency, trust, and providing information to the people who provided the funds to do that research, right? So giving back to the public. You can do all those things without making data fully open access, right? So I'm going to go quickly through this because I'm sure the FAIR principles have come up in other contexts, but just as a reiteration, so FAIR is data are findable, accessible, interoperable, and reusable, and their catchphrase is as open as possible, as closed as necessary, right? That means you can make things open, and they can also be closed, and that also is open science. Yes? The more I say it, I feel like the more it's going to be a thing. So the FAIR principles came about from a community of practice of like researchers, librarians, infrastructure providers, all getting together and deciding that there are criteria on how you would define in a technical sense whether data are fair. These are at the end of the life cycle of your data project. You are trying to publish your data. You're trying to archive them or deposit them. Then data can be fair. They can't be fair if they're on your SharePoint server. That's like not a thing. So there's all these criterias for making data findable. So I have a sort of TLDR, like too long, didn't read. So what do I actually have to do? It has to be in a repository. And it has to have documentation, so metadata, and a persistent identifier, right? So it has to have like a DOI that points to that data somewhere that's registered. So if you change the URL of your data, there's still some way to find it. And being in a repository, what does that mean? So there's different kinds of repositories. We have an institutional repository at McGill called the McGill Dataverse. So it's based on open source software. It's part of a consortium of shared infrastructure service called Borealis. So the service is Canada-wide. Most universities have an instance or collection within Borealis. It's managed and run by folks at U of T, it's all the data is on their servers and servers in Ontario. None of these are really meant for sensitive data, except for there's ICPSR, which is based out of the University of Michigan, which takes social science data. It does have a access controlled repository as well. But then there's issues with collecting information in Canada and putting it on US servers. So usually it's not an option for folks here, but I just wanted to highlight there's domain specific, there's general, and then we have institutional. When you're depositing the data, it's not just the data set itself, it's all the information that you need to reproduce it. And this is what plays into open science. If you put a spreadsheet in a repository under a fully open license, it's to the public domain. I have no copyright, do whatever you want. It has no description. It has no code book. It has no metadata. It is not open. Like you cannot use that for anything, right? So doing open science is also thinking about all that information you need, all that metadata you need, the data about your data set that will make it usable or that other people can use it to even verify your findings. What computing environment? Does it need a container? All those kinds of things. Accessible, here's the critical thing. It does not have to be open access. Accessible just means the data or the metadata about the data, so not the data specifically, but some information about the data have to be in an open public repository. So that doesn't mean you can download the data from the repository. It means you can find a page that describes the data on an open public repository, that you don't need to log into the repository, but you can just see it just from searching around. And metadata should be both human and machine readable. Again, like some examples of like things like human readable means like an abstract for your data set. Like, what is it? And since I manage our data repository, I get tons of deposits from all sorts of different disciplines. So I'm like, if I can't understand what your data set is from the abstract, I'm going to send it back to you and be like, write a better abstract. Because like, I don't know what you're talking about, or at least say you should be in this field. Otherwise you won't have any idea what I'm talking about. But some of them are just like a data set for my thesis. I'm like, what thesis? Whose thesis? Where's the thesis? What is it about? I don't know. So things like a notes or description, that's for the human. The human finds the web page and is like, what is this? You have to read something. Word document. Then there's machine readable metadata, and that's so when you search in Google, Google can find that data set. So there has to be something where those machines can talk to each other and retrieve information and give it to you in the results. That's what metadata is for, the machine readable, things like your ORCID ID. What publications has this researcher produced? This is their ORCID profile. Oh, I can just go to their ORCID profile and return those results to you in Google, right? Things like a CSV file can be parsed by machines, right? It knows what the delimiter is, so it can parse information. Creative Commons licenses are machine readable. So if you want to go into Google and say, I want open access data sets about this topic, it will filter based on licenses that have been attached to data sets in repositories, right? And should return, who knows what Google is doing, but it should return open access data sets. Things like the ISO 8601 date format. So that's a date format that can be read by even Excel, believe it or not. It knows that's a date. So, this is a sort of international standard for dates, so that when you're saying I'm looking for something within a range, the machine can restrict all the results to that range, because it can be like, that's a date. I understand, Okay, interoperable data. The TLDR is that it should be an open file format. So making data openly available or doing open science, it's not SPSS files, it's not Stata files, it's R files, it's CSV. So part of that is to mitigate against the obsolescence of proprietary software over time, right? So in 50 years, can we open that file? If you use an open format, it can be opened in whatever software. If you use a proprietary format, who knows? Good luck, So that's the kind of thing to think about as well, is if you put something somewhere and you put it into a file format that then in 10 years cannot be opened, or you need to go to a special library that has computers from this era with like disk drives from this era, and then it can read whatever the data is, that's not really doing open science, right? So I have a list here of like some common preservation file formats. So we call them archival file formats, preservation, or open file formats. Things like CSV, .text instead of Word. There's an image format that preserves well over time versus others. That's TIFF or JPEG, things like that. And then what's reusable data? So this actually doesn't mean you have to be able to reuse it. It means it should have a clear terms of use, or a license attached to it. So people know whether they can reuse it and under what conditions can they reuse it. So you can make sensitive data fair without using an open license, and it's still fair. And you're still making all that information available so that people who should be able to use it for the purposes that participants have consented to will be able to. That's sort of what we're trying to achieve. And so just an overview of open licenses versus other kinds. So if you have out-of-the-box ones you're using in a repository, you might see that there's CC0. That's no copyright. It's dedicated to the public domain. People don't even have to cite you. They can literally take it and do whatever they want. CC BY, it's the same, except they just have to cite you, but they can still do whatever they want. And there's no restrictions. So right now there's this big debate with like REBs around Canada and people in my position, like RDM people, being like, okay, the TCPS2 panel has said it's okay, like putting something in a repository doesn't mean that you're violating that no restrictions thing or that specific use, but there's no guidance on what if you put an open license on it. And that's where we're having debates right now about, do these licenses actually work with our guidance? And if not, should we be sort of thinking about other kinds of licenses, not as antithetical to doing open science, but as the necessary control on things that you're trying to make as open as possible, right? So something to consider. And I'm not going to get into so much about Indigenous data sovereignty, except to say that this is like a distinctions-based approach. So this adds another layer of consideration when working with data and another layer of sensitivity around the data. And in some cases, this will like contradict open science, and that's fine, right? So this is a context where we would have to be careful to sort of respect what the community that's involved in the research wants over considerations about open science, because that's sort of the ethical framework that guides that kind of research. And just a plug for the OCAP course that the First Nations Information Governance folks offer. It's based out of Alberta, but it's an online course. It's only relevant to First Nations in Canada, so it's not a broad set of principles. Each First Nation can decide whether this is something that they feel is a good framework for their context or not. So it doesn't necessarily apply. So something to be careful about is to say, like, we're going to follow OCAP when we do this work. That has to be negotiated with the First Nation. That has to be something that's agreed is the framework that makes sense for that community. But I do recommend it. It is a really good overview. Just FYI. Okay, I'm almost done. I'm wrapping up, and then there'll be questions. So I have a data checklist for FAIR, and what I wanted to point out here is that it doesn't say anywhere that it has to be open access, right? So your data can be FAIR if it's in an open repository, but the data itself does not have to be just click to download it. If it's in an open repository, you're doing open science, you are making the data FAIR. Does it have a registered DOI? So can it be tracked? Are the data files in open formats? Can the metadata be retrieved or discovered through an open search protocol, usually? So if you go to Google, can you find information about that data? Can you find something that describes it? That's the important aspect there. Do you have documentation and metadata with the data set that sort of includes things like explaining jargon or a code book or things like that? Acronyms, what are the acronyms? We love acronyms in Canada, so like we have to explain them to people. Are we using machine readable standards where available? Have you linked the article that's related to that data set, right? Have you put those two things together so that people who find one will find the other, and it's easy to find the data set associated with the article? So that's a sort of clear way to increase the transparency around the work that you're doing. And then have you assigned a license or terms to that data set? It doesn't have to be open. You just have to have terms so that people know what they can do with it. So basically, here's what we recommend for I don't know if there are workarounds, but there's sort of like the best that we can do right now when you want to broadly share or deposit sensitive data. So data that cannot be stripped of its sensitivity in some kind of way, right? So it could still mean you've done your best effort to reduce anything that could identify people, but you feel that there is still some sensitivity with it. A lot of qualitative research is falling into this bucket right now. So like if you have interview transcripts, I'm even working on projects where I'm consenting people to deposit data, and I don't think we will do it in the end, just because even if you remove all the identifiers, people could take that stuff out of context. We just don't know like what things can be connected. If the way people speak in some point can be analyzed and compared to things that they've said in other places or videos of them. So there's not a good answer. So right now, a lot of the time the REB will say like for qualitative data, you have to like really have more consideration about how specific is it, how much information is it, are there other things involved with that, and should it really be open, or like what can people really do with that in terms of reuse or verification, especially because the point of qualitative data is not necessarily to replicate findings. It's someone's subjective understanding of like the information and their perspective of what the interpretation is. So there's a bit of a debate about that as well. Some workarounds include creating a metadata page in a data repository. So that's where you go to make a deposit. Like you say, I'm going to upload data, I'm going to describe it, but you actually don't upload the files. So you just have a description of it, it gets a DOI, but you have to have some explanation of how someone can access the data if they have the right to. In some cases, it's like you must sign a confidentiality agreement. We will transfer it to you this way, and that's how you will receive it. These are the things you can do with it and the things you can't do with it. So there could be a lot of restrictions, but you're still allowing someone the chance to go through that process, and that's clearly explained. And that process is publicly available. So someone can find that and understand that without having to email someone and be like, can I have your data? And then never hearing back from them. You can consider a data repository with access controls, meaning it could still have a public-facing page and the files could be there, but the repository itself brokers access to it, right, in some kind of way. Of course, there's always sharing the anonymized version of a data set. So you might have a sensitive version and then you might have another version of it that gets shared. Again, you'd have to take all of these other considerations into account. There are some pilot projects spinning up. So FRDR, the Federated Research Data Repository, it's a Canadian repository. It's free for researchers at Canadian institutions. They have started a pilot project to host encrypted data that would then have some kind of committee that would review access requests to the data. So it's an open data repository right now. You can't put access controls on the data. They are spinning up a sort of version with access controls. They're doing this pilot at UDEM, actually. So as far as I know, what they have right now is they've put a data set there that's encrypted. And so basically, if you wanted access, you would get an encryption key. And if they acknowledge that you should have access to it, you would get the key to decrypt it. And then you would have to follow some steps or whatever. But so they put it there. Now they're working on the other side where someone requests it. And then they're going to see how that works. But it's moving forward. So that might be available at some point. But basically, just to say that FAIR is open science. So it's open access data is fine for a lot of things. If you have sensitive data, FAIR is the way to go because you can make your data fair and it doesn't have to be open access, but you have done all these things that are consistent with the foundational principles of open science. And I just wanted to highlight a quick example. I know we're out of time, so I'm just going to show it here, but actually I'm gonna go to the website, and this is my last thing. But I just wanted to show, oof, I lost it. I'm gonna try to ish. Okay, well, I just want to show in the McGill Dataverse, there is the COVID-19 Immunity Task Force, which is out of the RIMUHC. They had sponsored a bunch of projects about COVID over the last few years, and now they're publishing harmonized data sets from this study. But they have two versions. They have an open dataverse where they have a ton of the study data sets that are anonymized or not sensitive or not from humans, for example. And then they have a controlled access data bank. So if you want to see what it looks like to have a sort of data set that doesn't have data, you could go into this one and take a look. But for example, they have a study here. They have a lot of description around it. They have a really good guide for what kind of metadata they're going to put into the data sets that they're depositing. And you can see there's no files in this data set. So if you go to their custom terms, says that you have to go to their portal, their data access portal, to request access to this data set. But people can find it. So if a study is published using this data set, they can come here and they have a clear way of accessing the data if they have the right to access it. And this is because this is microdata. So this is this is at the observation level of patients, and it's not data that can easily be de-identified or anonymized. Or you want it with the identifiers, and there's some process you can go to. So just to point out that this is what it would look like. It's in an open repository. It's published. It has a citation. It can be cited in the articles, but the files aren't actually there because we don't have that infrastructure with this repository to manage that. And spinning up your own controlled access repository also has a whole host of issues. So in the meantime, this is one of our best options that we have available. But hopefully in the future, we'll have more ways to share that. So I'm just going to quickly say thank you and see if there's any questions.